Number 24. The amplitude of a sound wave is measured in terms of its maximum gauge pressure. By what factor does the amplitude of a sound wave increase if the sound intensity level goes up by 40 decibels? Alrighty then. So basically, right, we have to find how does the amplitude increase when the sound intensity level goes up by 40. So basically what I need to do, I know I'm dealing with sound intensity level, I'm dealing with then beta, right? Let me draw it down here. I'm dealing with beta. And somehow I have to relate beta somehow to amplitude. I'll just label that as capital A. Now, do you have a formula? Now, how I like to do this then is to think, well, do I know a formula that relates these two things? And we look over here on the right-hand side and there is none. So what I now need to start doing is start figuring out the pathway, basically, to get from beta to amplitude, okay? Now, they give me one other key piece of information in the problem. They say the amplitude is basically measured, right, as its maximum gauge pressure. So now I'm thinking, well, okay, amplitude and pressure are related. So maybe if somehow I can get from, let's say if I can get from the beta sound intensity level to then the gauge pressure, little p, then maybe I can relate that to the amplitude somehow. So the question now becomes, all right, amplitude is simply just measured as gauge pressure. So now what I need to basically do, and this is just increasing by a factor, right? We don't have to find the actual amplitude. So all I need to do then is try to figure out, do I know a relationship between then the beta or the sound intensity level and pressure? And again, we look on the right-hand side and we don't find, right, a direct relationship. So then I say, okay, this is just fantastic. So now I'm thinking to myself, well, how is pressure then related to beta? It's not directly, but there might be a variable in between. So then I start looking through the formulas and I realize that the formula that the that the intensity level is equal to the pressure squared divided by 2 times density, blah, 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 right? So I realize that actually pressure is related to intensity. And then I make the connection, oh my goodness, right, intensity is related to then the sound level via that log formula, right? So that's the key, right? So basically beta is then related to, I could say beta is basically now related to intensity, and then the intensity is related to pressure, and then finally then I could relate the pressure to the amplitude, right? So the relationship's going to look like this. Okay, so hold on to your seatbelt, ladies and gentlemen. The ride's going to get a little bumpy. So now what we need to do basically is we have to start setting this up. So first thing I want to do is I'm actually going to work kind of backwards. All right. I know I have to find because I have to find the factor the amplitude changes by basically. And I know amplitude is measured via pressure. So what I want to do is I want to solve my equation for pressure. And what equation? Well, that equation we had before, that the sound intensity level is equal to delta p squared divided by this mumbo jumbo at the bottom, 2 density multiplied by the velocity, okay? Now solve this thing for p. So you cross multiply, right, and then you got to take the square root. So we're going to have the square root of the intensity multiplied by 2 times the density times the velocity, okay? Now, if I want to call this the second pressure, right, because remember we're finding a factor, then I would have to call this the second intensity. And since I'm trying to find a factor, basically whenever they start saying factor, how much does it increase by, or blah, 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 I know I'm setting up a ratio of some sort, okay? So let me just move this little thing out of the way somewhere that, yeah, there, oh, it fits perfectly there, right? So I know I need to create a ratio somehow. So basically I'm going to start with this, right? And then I'm going to divide it then by the first one, right? I want to create a little ratio. How many times does how many times does the pressure increase? So if this value were 1,000, and this were 1, then I know it's 1,000 to 1. It increases by 1,000 times, right? Et cetera, et cetera. So now I'm just going to set this up. So this becomes I1 times 2 rho VW. Now realize that when we do this, right, I can basically now take, and I should really be doing this on the side. I can really now take the P2 over P1, and then since both of these are under the square root, I can make a big square root, right, over both of them. Okay, and then it's going to be I2 times 2 rho VW all divided by I1 times 2 rho VW. And what do you notice? We can cancel these, right? So notice already that it looks like it was complex to begin with, but now it's starting to be simplified already. So now here's the P2 relative to P1 would be equal to simply the square root of then I2 relative to I1. Okay. Now I start thinking to myself, okay, well this is great. If I knew the relationship between the intensities, then I can find the relationship between the pressures. However, though, they didn't tell me the intensity, right? They told me the sound intensity level, and that level means that it's in decibels, and that's what they told us, all right? So now basically what I have to do is just like on my map over here, right? I have to now, I work with P and I found this relationship to I, and now I got to relate I to beta, and then because that's what was given, and then I can finally probably conclude, all right? So now, how is I, so let's put this on the side for right now, put a little box around it. Come back to it. How is now I related to beta? Well, that's via the sound intensity formula, right? This we used tons of times now. So this is the sound intensity level beta is equal to 10 multiplied by the log of base 10 of the sound intensity level divided by the threshold of hearing I sub O, which is 10 to the minus 12th. All right. Now, what I want to do is I want to solve this thing for intensity. The reason being is because then I can plug that result on into my formulas here, right? And then maybe I can start to figure this thing out. So now, why don't we divide both sides by 10, right, to cancel the 10. So this would simply be then beta over 10 would be equal to log base 10 of I over 10 to the minus 12th. Now I want to get rid of the log because remember my whole goal here is I'm solving for I. Okay, so I got to put a base of 10 on both sides, and then those values become basically the exponents, right? So this is beta over 10, and this is 10 raised to the log base 10 of I over 10 to the minus 12th. And I realize that the base 10 cancels the log, that's the whole point, right? And now we're going to get simply, and 1 second, let me go to blue. So now I realize that becomes a normal fraction. Intensity is going to be divided by 10 to the minus 12th, and that's going to equal now 10 raised to the beta. 10 raised to beta all over 10. Okay. Now multiply this on out, right? You might say, well, how can I remember? Whenever you have like bases, you can simply add the exponents, right? So it's beta over 10 plus a negative 12. So now we realize that the intensity level here is going to be 10 raised to the beta over 10 minus then 12. I know this looks crazy and it's going to get even crazier, but this is what we got to do. So now what I can say is this is the general formula. If I want to plug in my second intensity, then I would be plugging in my second sound intensity level, my second decibel value, right? So I can put this as a little 2, and that is a little 2. I could also have placed a little 1 here and a little 1 there, right? So that's basically what I'm going to do now when I plug it all into my formula. All right, so let's just take this, we'll move it on up to the top here. I'm going to erase some of this work just because we need space. All right, and now what I'm going to do is I'm going to plug in that result into my formula over here. So, and I'll move this a little bit more front and center. So now we're going to have P2 all over P1 is going to be equal to now square root of, and let me make that a little neater. Thank God for autocorrect. We're going to have I2 now, right? So I2, and we define that as now 10 raised, and I got to leave myself a little more space, 10 raised to the beta 2 all over 10, right? All over 10 minus then 12, and that's all in the exponent, so just be careful, minus 12. And now that's all over then, base 10 raised to the beta 1 all over 10 minus 12. Okay, so hopefully, let me try to make that a little neater. Beta 1 all over 10 minus then 12. Okay, so now I realize that, well, all right, I have two unknowns, so I gotta do one more simplification, all right, before we can rock and roll here. So now what I realize is, once they start telling me, it says, what factor does the amplitude of a sound wave increase if the sound intensity level goes up by 40, right? So that means that assume you have a beta 1 value. Let's just pretend that that was 10. And then you had a beta 2, what would it be? Well, obviously it'd be 10 plus 40, right? Which would be 50. Okay. What happens if this were then 5? Well, then your answer would have been 45, right? Why? Because it would have been 5 plus the 40, which would be 45. So basically what we're saying is this. You can basically take your beta 1 value, right? So beta 1 is equal to, let's just say itself, beta 1. All right, I know that's a little strange. And then beta 2 would be equal to, right, beta 1 plus then 40. Doesn't that make sense? Right? If the sound intensity level goes up by 40, that means the second beta value would be the original plus 40. So now what I can do is through this equation right here now, all right, I'll put a little box around that one. All right, through my equation here now, I can basically substitute now the this value here, beta 1 plus 40 on in for beta 2 here. Okay, so let's do that. All right, so now it becomes, well, actually, you know what? Before I do that, because it's going to get a little messy still. Before I do that, that will come next, but instead I'm going to do the algebra in here first. Now remember, anytime you have, if you have 10 raised to the a divided by 10 raised to the b, you can rewrite that as 10 raised to the a minus b, right? Just rules of exponents. So this is your a here. Let me color code this. This is your a, just a pretty big mess. And this is your b, just another big mess. But the principles stay the same. So watch. So now what I'm going to do is I'm going to say P2 over P1 is going to be equal to the square root of, this will be 10 raised now to the a value, which is beta 2 all over 10 minus 12, right? And then I'll put this in parentheses. If I, minus then, I'll put this in parentheses, the b value, right? Beta 1 all over 10 minus 12. Now remember, all of this is in the exponent. Now how do we simplify the exponent? Well, we can simply now distribute if we like, right? We can say now this will be P2 over P1 is going to be equal to now square root of 10, and bear with me here, ready? This is going to be 10. Now the negative distributes to the beta 1, so this is negative beta 1 over 10, and realize that we have like bases here with fractions, so I can rewrite this as one whole fraction, right? Beta 2 over 10 minus beta 1 over 10 would be simply beta 2 minus beta 1 all over 10, okay? And then minus 12 minus a negative 12, oh, goody golly, right? Negative times a negative is a positive, then you got positive 12 here and a negative 12, so they just cancel. So that is fantastic, right? So this is literally now what it works out to be, this fraction. Okay, I'm going to box it. So notice here now I'm going to do my substitution. I could have done it before too, but, I figured this might be easier to do it this way. So now what I'm going to do is I'm going to substitute now, going back to my equation here, I'm going to substitute the beta 1 plus 40 in for the beta 2. Okay? So let's see. So now this is going to be P2 all over P1 is equal to the square root of 10 raised to the beta 1 plus 40 minus beta 1 all over 10. And look what happens. The beta 1 cancels with that beta 1 because they're being subtracted from one another. So this simply now will equal the square root of 40 over 10. And 40 over 10, to reduce down to simply just 4, right? So it's 10 raised to the 4th. When you take the square root of that, you can do this in your calculator now, but it simply becomes 10 to the 2. All right? So the pressure P2 relative to P1 is equal to 10 raised to the 2 all over 1, aka 100, right? This would be equal and equivalent to now 100 to 1. So it increases by a factor of 100. Oh, man. All right, ladies and gentlemen, we have arrived at our destination. Please take your luggage and have a safe rest of your trip. Take care.